Greetings, YouTube. Beautiful mind here. So this will serve as our lecture for week 5 Friday for support for college algebra. A few announcements. So, like one, I intend to get as many assignments loaded, the remaining assignments for the rest of the quarter as soon as I can. Exam 3 that's due next, not this Saturday, but next Saturday is actually already loaded. It should be already be loaded. So I'm just trying to give. I know that it's a lot of work. So nobody said it was going to be easy. Nobody said it's just going to be a cakewalk. So I don't mind loading something like this early to give you plenty of time to get it done. Like in the past, I would only give you a couple of days to do the exam, or give you an entire week, unlimited attempts. All right. Okay. I'll do my best to get other assignments loaded as early as possible. The final deadline for all submissions is going to be May 16th, right? So we're kind of entering the home stretch, about 2 or 3 weeks. Okay. I'll try to get I'm doing my best to get things loaded as early as I can once I get a sense of where we are going to be. Let me see if there's anything else. The main thing is just that exam 3 is already loaded. Okay, so you want to definitely go ahead and check that out. You'll get a week to do it, so you want to just go ahead and knock it out. I think that's it for this group. Okay, so your grade. Oh, let me do this. This might help with the audio. All right. Yeah, so your grade essentially comes from Pearson, right? That's how I'm keeping track of the grades. Keep in mind that you have support. I think for this group that we are required to do at least 2 hours of tutoring with the tutors, okay? So just do the best you can there. I think they've been logging that, so just make sure that you're doing that, and I'll link with the tutor to follow up about that. I see that the audio changed. Let me kind of redo the spiel again, just in case you couldn't hear me. So this will serve as the lecture for week 5 for Friday for support for college algebra. Exam 3 that's due not this Saturday, but next Saturday is actually already loaded. You get unlimited attempts for a week, okay? So that means you can get whatever grade you want. It just has to get the assignment submitted. I don't mind loading assignments early because I know that we might be a little overwhelmed and we're kind of reaching that point. So I'm doing my best to try to create as much of a cushion for you, but you gotta meet me halfway. I can't just give things away. You still have to meet me there. And I just know it's tough. That's just the nature of mathematics. It's just tough. And then my energy, I know it can be a little bit difficult, to kind of vibe, because I know my energy is dense. So I don't try to adjust that anymore. I just try to work with it. Let me see if I can think of anything else. Yeah, so exam 3 is loaded. Okay. After exam 3, maybe a couple of more assignments, and then the final. I'll try to get that loaded early too, so you can kind of be working on that too. You get unlimited attempts. A final exam will be cumulative. The last day of submission for all assignments is May 16th. That following Monday is going to be our last class. I'm really just doing that to just try to. I'm probably going to have that final exam loaded kind of early, and I want to use that last day. That's going to be. I really want the time after that Saturday just to just make sure that old assignments are submitted, everything is submitted, and we're good and ready to go. Okay, I can't think of anything else. So today I'd like to take a look at sections 9.4 and 9.5. Section 9.4 is on dividing square roots. So we're going to continue this discussion on radicals. So we're going to look at dividing square roots. So some objectives here are one is to understand what it means for a square root to be simplified. 2, use the quotient rule to simplify square roots. 3, rationalize denominators. 4, rationalize denominators using conjugates. Okay. A square root is simplified when 1, no radicand, that's the inside part of the radical, has a factor that is a perfect square. No radicand contains a fraction. No denominator contains a square root. So those are the 3 conditions that we have that indicates that a root is simplified. So all 3 criteria must be met for an expression to be simplified. Below are some radical expressions that are not simplified. Notice with that square root of 8, you have a perfect square factor in there because 8 is 4 times 2. 4 is a perfect square. Square root of x cubed has a perfect square in there, so that's not simplified either because you can break that apart into x squared times x. We have a fraction inside the radical in that third example, so that one's not simplified. And we have a radical in the denominator, so that one's not simplified. And that last one. So quotient rule for square roots. If we have the square root of a fraction, we can rewrite that as the square root of the fractions. Yeah, if we have a square root of a fraction, we can rewrite that as the fraction of the square roots. And if we have the fraction of the square roots, we can rewrite that as the square root of a fraction, provided that A is non-negative and B is positive. Okay. So we have this example and we're asked to simplify. Should I have more colors? That would be nice, but we'll go with this one. Oops. See if I can get this to behave properly. There we go. Well, I guess that has to be. All right, well. So in this example, we're asked to simplify. I typically like to start with a copy, so I'm just gonna give myself a copy. We got 10x squared divided by 5, and we have the square root of all of this, all right? Let's see. I'm actually gonna, there's a couple of routes. There's more than one correct way to go about this. I noticed that we can simplify the fraction. I just want to simplify the fraction first, so I'm just choosing a route. So notice that 10 divided by 5 is going to be 2, right? And then this stays. But then we can rewrite this as the square root of 2 times the square root of x squared. And the square root of x squared is just x. So we're going to write this as, I'm going to write it in this fashion, x times the square root of 2. So that way it's clear that the x is not inside the radical. Okay, let's see, how do we do? First, divide out any factors common to both the numerator and denominator, then simplify. Yeah, we did that. That's what we did, and we got that exact same answer. Notice if we had put the x behind the square root of 2, it might not be clear if the x was inside or outside the radical, so that's why I put the x in front of the radical. Okay, let's give these a go. Notice this cancels this. This turns this into a 40. So then at that point, we're going to have 40. Nope, that's not a 40. So we're going to have 40 a squared and the square root of all of that. 40, let me see. We got 4 and 10, right? So 40, we can do this as the square root of 4 times the square root of 10 times the square root of a squared. The square root of 4 is 2. The square root of a squared is a, and there are no perfect squares inside the 10. The 3 turns the 48 into, let's see, there's a 1 and a 6. Okay. This turns this into a 2. So at this point, we have y to the 4 divided by 16x squared, and we're taking the square root of all of that. Okay. So then this can become, so we have y to the 4, we have the square root of that, divided by 16x squared, the square root of that. So remember, we just say all the exponents divided by 2. So that's going to become y squared. Square root of 16 is 4, and x. Okay. Okay. Let's see. This turns this into a 4. This turns this into a 4. This turns this into a 1. This turns this into a 5. Okay, let's see if we can account for those changes. So on top, we still have a 5 b to the 4 c divided by a to the 4, And I think that's it. We're taking the square root of all of that. So I think the square root of 5 is going to persist. The square root of b to the 4 is going to be what? B squared. We still have the square root of c divided by square root of a to the 4 becomes a squared. So then one more step. We can finish as b squared times the square root of 5c over a squared. Okay, let's see how do we do. Okay, that looks good. Y squared divided by x, let me see. 4x, okay, that's fine. Should have glanced at the last one, but that's okay. Yeah, I think we got that. All right. All right, let's keep it moving. So rationalize a denominator with a square root. To rationalize a denominator with a square root, multiply both the numerator and the denominator of the fraction by the square root of a number so that the radicand of the denominator becomes a perfect square, right? So we're going to multiply by 1 in the form of one square root over another so that the denominator becomes a perfect square, okay? So we're asked to simplify this. So if we have 1 divided by the square root of 5, so we're going to multiply by 1 in the form of square root of 5 divided by square root of 5. All right. So now if we do this, the following happens. On top, we just have the square root of 5. On bottom, we're going to have the square root of 25. All right. Let me do this so you can keep track of what's going on. So we're going to say this times basically 1 equals that. Okay, square root of 25 is 5, so this finishes as the square root of 5 divided by 5. Okay. So now we want to look at a technique for rationalizing denominators using conjugates. In general, the conjugate of the binomial a plus b is a minus b. So for a radical expression, if we have 8 plus root 2, the conjugate is going to be 8 minus root 2. If we have root 3 minus 4, the conjugate is going to be root 3 plus 4, so on and so on. Okay, so we're just changing the sign of that middle symbol. Okay, in this context. So we're going to use the technique of multiplying the top and the bottom by the conjugate here to rationalize. Okay. So what's the conjugate of the denominator? We're going to multiply the top and the bottom by 2 minus the square root of 3. Let's just see what happens when we do this. 2 minus the square root of 3. So we're still multiplying by 1, but now we're multiplying by 1 in the form of the conjugate over the conjugate. Okay, now on top, we're still going to have this 8 times 2 minus the square root of 3. On bottom, we're going to have to use the technique of FOIL. Okay, let's use this color. So we want to FOIL, F-O-I-L. It stands for first, outer, inner, and last. Okay, so this is our first times our first, outer times outer, inner times inner, and last times last, like that. All right, that's FOIL. Okay, so if we do this, first times first gives us 4, outer times outer gives us minus 2 times the square root of 3, inner times inner gives us plus 2 times the square root of 3, and last times last gives us minus the square root of 9, right? So then, square root of 9 is 3, so 4 minus 3 becomes a 1. Oh, that becomes 1 on the bottom, right? This cancels this, We get a 1 on the bottom, and on top, if we distribute, ooh, top if we distribute, 8 times 2 is what? 16 minus 8 times the square root of 3. Okay. Sixteen times 16 minus 8 root 3. Let's see, how do we do? Cool. All right. Let's give this one a go. Same technique. So we're going to rationalize by multiplying the top and the bottom by the conjugate. Okay. So again, we're still using the technique of multiplying by, let's do it like this. We're still multiplying by 1, but we're going to multiply by 1 in the form of the conjugate over the conjugate. So we have this 2 minus the square root of 6 under the square root of 3. The conjugate is going to be what? So we're going to multiply the top and the bottom by 2 plus the square root of 6. 2 plus the square root of 6. So we're multiplying by 1 in this form. Okay. So let's see what happens here. Again, we're going to distribute, and we're going to FOIL first, outer, inner, and last. Okay. So if we do this on top, we're going to get 2 times the square root of 3 times the plus the square root of 6 times 3 is 18 over, let's see, 2 times 2 is 4 plus 2 root 6 minus 2 root 6 and then plus the square root of 36. Kind of out of space there. Okay. 18 has a perfect square in there. It's 9 times 2. So we're gonna on top we're gonna have 2 times the square root of 3 plus 3 times the square root of 2. Notice that this cancels this. Square root of 36 is 6. 6 plus 4 ends up being 10. So more than likely they want it to look like this. We're going to have the square root of 3 divided by 5 plus 3 divided by 10 times the square root of 2. Something like that. All right. Let's see, how do we do? Uh-oh, looks like I made a mistake. Oh, minus. See, that's what happens when you run out of space. It sure is. Yep. Okay. So this is wrong. Let's go here. We gotta fix it. So let's see. Right here. This is supposed to be a minus. So I'll do that in red. It was supposed to be a minus there. If that's a minus, then what happens? That's a minus. Oh, I'm just so sleepy. Let's get rid of all of this. Yeah. All right. So now let's account for those changes. So then 4 minus 6 is going to be what, a negative 2 there, right? Okay, that's better. So then negative square root of 3 minus 3 over 2 root 2. Okay, let's give this one a go. See, how do we do? Oh, they left it like that? That's interesting. I guess so. That's fine. It's the same thing. I just distributed the 2 into both parts, but it's the same answers that we got. Okay? All right. So that closed out section 9.4 on dividing radicals. Give me a moment so that I can load 9.5, and then we'll call it a day. All right, and we are back. All right. Oh, okay. Give me just a moment. Okay, sorry about that. All right. So yeah, wasn't displaying properly. Okay, so continuing chapter 9. This will probably be the last section we do in chapter 9. We'll do section 9.5, solving radical equations. Some objectives here are to solve radical equations containing only one square root, solve radical equations containing two square roots. Let's see. A radical equation is an equation that contains a variable in a radicand. Okay, so an equation that has a variable inside the radical, or in the radicand, I guess. Let's see. So to solve an equation containing only one square root, rewrite the equation with the square root by itself on one side. We call this isolating the square root. Then we want to combine like terms. We want to square both sides of the equation to eliminate the square root. Solve the equation for the variable. Check the solution in the original equation for extraneous roots. Okay, let's see this in action. So we're asked to solve the equation. Okay. So I usually like to start by getting a copy of the original. We have this 2x minus 3 square root equals 5. Notice that the square root was already isolated. Right? So since the square root is already isolated, we're going to square both sides. Okay. So then on the left, we're going to have 2x minus 3. On the right, we're going to get 25. If we keep going, we can add 3 to both sides. We get 2x equals 28. All right. Divide both sides by 2. X equals, what is that? 14. Okay. So with something of this, we can actually check before we go forward. All right, so if we get an answer of 14, let's check. So if we're going to check, we want to know, is 2 times 14 minus 3? If we take the square root of that, the question is that equal to 5? 2 times 14 is what, 28? We're going to have 28 minus 3, square root. Does that equal 5? 28 minus 3 is 25, square root. Does that equal 5? Yes, 5 equals 5. It checks out. So we can stand by this answer of 14. Okay. Let's try another one. We're asked to solve this equation. Okay. So we have this 2x minus 3 square root equals x minus 3. Notice we've already isolated the square root. So again, we're just going to square both sides. We're going to say this squared and this squared. Okay. On the left, essentially that cancels that. So we're going to be left with 2x minus 3. On the right, we're going to FOIL. So if we have x minus 3 squared, this what we have is x minus 3 times x minus 3, right? So if we FOIL that out, we'll get x squared minus 3x minus 3x plus 9. We got this 2x minus 3, right? So then let's set it to 0 and solve, combine like terms and all that stuff. I'm going to move everything to the right and then flip it, all right? So then if I do that, I'm going to get x squared. Let's see. So negative 6 minus 2 is negative 8x. 9 plus 3 is 12. That's 12 equals 0. So I moved everything to the right using the inverse operations. And then I just switched it around because I wanted my 0 on the right. All right. So then we should be able to factor this. Can we factor this into something of this form? We have x and x. That second plus tells us the two signs are the same. The first sign tells us that they're both minus. It tells us that the larger one is minus, so therefore they both have to be minus. Can we find two numbers that multiply to give us 12 and add to give us negative 8? Let me see. It's not 1 and 12. 2 and 6. Right? So then 2 and 6. Notice that negative 2 times negative 6 is positive 12. Negative 2 plus negative 6 is negative 8. Okay? So then from here, from the zero factor property, when we have two things that multiply to give us 0, either x minus 2 equals 0 or x minus 6 equals 0. If we solve those, we ultimately get what? X equals 2, 6. We get x equals 2 or x equals 6. But we need to check. Sometimes what happens with this is we produce what's called right-wrong answers. Algebraically, it works out, but we will produce answers outside the domain of the original, and so they don't actually work. So we need to check. Let's check. Okay. Let's start off when x is equal to 2. We got 2 times 2 minus 3 square root. The question is, does that equal to 2 minus 3? 4 minus 3 is a 1. So on the left we get 1. But on the right, 2 minus 3 is negative 1. So that's a no. So we can't keep the 2. All right, let's try when x is 6. Okay. So when x is 6, let's see, 2 times 6 minus 3 square root. The question is, does that equal 6 minus 3? 6 times 2 is what? 12 minus 3 is 9. Does that equal to 3? 3 equals 3, and that checks out. So then the only one that we can actually keep is x equals 6. That 2 is what's called an extraneous solution, or I like to call it the right-wrong answer. Algebraically is correct, but it actually is a number outside the domain of the original equation. So we can't keep the 2. Okay. So we got an answer of only 6. Let's see, how do we do? But again, we need to check. So the 6 was true, but the 2 was false. So then the only solution is x equals 6. Solving radical equations containing 2 square roots. To solve equations with 2 square root terms, rewrite the equation when necessary so that there is only one term containing a square root on each side of the equation. So you want to do your best to get, not do your best, but still isolate one of the square roots, right? Get one of the square roots by itself, and then you can square both sides, all right? Proceed like we did before. Okay, so let's do this. We have 7x minus 17 square root we're going to set that equal to 4x plus 1 square root, right? So we've already isolated one of the square roots, so now we're going to square both sides. Okay. So then essentially this is just going to cancel the square root symbols. So then we have the square root, we have 7x minus 17 equals 4x plus 1. If we subtract 4x on both sides, we'll get 3x on the left. If we add 17 on both sides, we get 18 on the right. Divide both sides by 3, x equals 6. Okay. So now we need to check. So the question is 7 times 6 minus 17 and the square root of all of that, does that equal 4 times 6 plus 1? Square root of that, all right? $36, 42. 42. It's like almost 5 in the morning. 42 minus 17, square root. Does that equal 6 times 4 is 24 plus 1 square root. 42 minus 10 is 32. 30 minus 5 is 25. So on the left we get 25 square root. On the right we get the square root of 25. Does 5 equal 5? That's a yes. So we're going to stand by this answer. Okay. All right, let's give this one a go. So let's see, we have this 4 times the square root of r minus 4 minus the square root 10r plus 14 equals 0. Okay. So first we're going to isolate the square root. We're going to move that square root of 10r plus 14. We're going to use the inverse operation to move it to the other side of the equation. So then what's going to happen, on the left we're going to have 4 times the square root of r minus 4. On the right we're going to have square root of 10r plus 14. So then now we're back to the previous example. Square both sides. Okay. 4 squared is 16. So let's see, that's going to be 16 times r minus 4 equals 10r plus 14. Okay. Okay. Let's see. So we can, distribute combined like terms and set it to 0. So I'm going to do a few steps in one go here. We can distribute this, and I'm going to just move everything to the left using inverse operations, right? So on the left, we're going to get 16r. 40 plus 24 is 64, so it's going to be minus 64 minus 10r minus 14 equals 0. 16 minus 10, that's going to be 6r. Negative 64 plus negative 14, negative 78. So then we get 6r, 6r equals 78. Divide both sides by 6, and r equals, let me see, that's a 1, r equals 13, all right? And we need to check. So the question is it the case that 4 times the square root of 13 minus 4 minus 10 minus the square root of 10 times 13 plus 14, out of space. Question is, does that equal 0? Okay. 13 minus 4 is a 9. Square root of 9 is 3, so that's going to be 12 there. Minus. Okay. So we're going to have the square root. What is that? 130 plus 14. Question is, does that equal 0? It's going to be what? 144. So 12 minus the square root of 144. Does that equal 0? 12 minus 12. Does that equal 0? 0 equals 0. That's true. So we can stand by this answer of 13. Okay. All right. So on that note, we're actually going to end the session here. Just as a quick recap. So exam 3 is loaded. We're approaching the final steps, right? I can't think of anything else. The main thing is just to practice, get our assignments submitted, and know that you have support. The professors are here to answer questions. That's what I just a lot of times I'm just sitting here. I'll game just to kind of keep myself awake, but I'm just kind of like monitoring my emails, waiting for people to ask questions. People typically don't ask me questions for one reason or another. Intimidation. I'm like, you guys don't have to be intimidated by me. Like, I promise you, I'm not anybody. I just talk math. I might be a little irritable, but I don't really mean anything. It's like, just ask questions. Like, it's okay. Like, it's okay. Like, my job is to answer your questions, but if you don't ask questions, then I want to see you all do well too. Like, and I know it's a little bit, it's an adjustment. Like, not only are you adjusting from, I don't know how many of you are still in high school or not, but not only making the adjustment of shifting from high school mentality to collegiate mentality, but on top of that, dealing with COVID, it's a lot. It's not easy. It's already hard by itself, but then you want to go and pull this, as far as society wants to pull this whole thing, or life. But that's how life goes. That is life. Like, that's what happens. Like, you make a plan, and then it seems, what I've noticed is that it seems like, if you have a plan, things typically don't go according to plan, but it'll work out. And when you don't have a plan, it just doesn't work, right? That seems to be what happens so far. So you just make a plan, do your best, forget the rest, don't stress, and be blessed, and just keep it moving, and continue on your quest. Anyway, okay, so we're entering the home stretch. Just the best thing is just get your assignment submitted, and that's more than enough for what I need to keep you moving. We get unlimited attempts at these assignments until certain dates. Everything has to be submitted by that Saturday on May 16th because we have to process grades and get things submitted. I think the last day of class is that Monday. I'll probably get that final exam up a little bit early as I can, so that you all can be working on it. Okay. But yeah, we're entering the home stretch. Okay, I can't think of anything else. And so on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.